This new project, Pedler, reminds me of VLLM. Sometimes back, I did a comprehensive video on VLLM if you're interested, which is a high throughput and memory efficient inference and serving engine for LLMs. This new project, Pedler, is sort of a load balancer or a reverse proxy if you are running multiple instances of serving engines or inference engines on the basis of llama.cpp. Llama.cpp is to enable LLM inference with minimal setup and state-of-the-art performance. It's a plain C++ implementation without any dependencies, by the way. Most of the tools you see out there these days are based on llama.cpp. One of them is LM Studio, which is one of my favorite to install large language models locally. Anyway, just imagine you are running multiple instances of llama.cpp, and each llama.cpp serving is serving a different LLM. So how do you combine them? For example, if a request comes in, how do you load balance? You don't want one instance to get saturated and you don't want other instance to stay idle. That is where this Pedler helps out. Also, more or less you can use that VLLM also for the same purpose. But this is sort of an open source project and alternative, and I'm more than sure we will have more choices in this as it evolves. So at a very high level, Pedler is an open source load balancer and reverse proxy designed specifically for optimizing servers running llama.cpp. Normally, people use strategies like round robin or least connections, and but they're not effective for llama.cpp servers because uh, llama.cpp servers need slots for continuous batching and concurrent requests. Pedler overcomes this by maintaining a stateful load balancer that is aware of each server's available slots, ensuring efficient request distribution. Also, Pedler uses agents to monitor the health of individual llama.cpp instances, providing feedback to the load balancer for optimal performance. Pedler also supports the dynamic addition or removal of llama.cpp servers, enabling integration with autoscaling tools. If you look at this architectural diagram of Pedler, it gives you a glimpse of how it works. So, for example, this is showing you how the llama.cpp instances get registered. The sequence repeats for each agent. Agent should be installed alongside llama.cpp instance to report the health status to the load balancer. And if you have worked with load balancers such as in cloud, for example in AWS, if you have worked with application load balancer, more or less it is the same concept where health check and liveliness is being done, and then load is being balanced among the instances which are alive and which are least used with the help of that Pedler agent. So installation of it is quite simple. If you go down, I'm not going to do it because I don't have llama.cpp instances running, but if you go here, all you need to do is to just do the latest release from its release page, which you can access here. I'm going to quickly show you. There are no releases at the moment, but I believe I saw some. I think that he removed it, but anyway, for now you can simply git clone this repo and build it from there, and then you can run these agents by using this command where you give llama cpp host the port and then all the information which is needed. That's it. And then you can also run the load balancer in two ways, like you want to um, in a management mode where it listens for update from agents, or you can also use it as a reverse proxy which can be reached from the outside host. Up to you. So amazing stuff. I think a very good project, really like it. And also the fun fact is that the creator of this amazing project, he called it Pedler because he wanted to use Raft protocol initially, but then he at the end he concluded that Raft was not necessary, but he kept the name Pedler. So really good stuff. Really like about it. Also, another thing which I like about is that it is something simple to scale from zero to any number of hosts that also support load balancing. So I think if you're running it in the production environment, for example, just to give you one of the architectural hint, maybe if you're using AWS's T3 or M5 instances and you're hosting some of the llama.cpp inference servers hosting a small model, and you want and each llama.cpp is hosting the same model, and you have placed some sort of load balancer on top of it, you can use Pedler. It is very easy, very scalable, and serves the purpose. Or if you are using it in your private subnet in AWS or in Azure or any other cloud provider where internet is not available directly, you can use this Pedler as a reverse proxy. So a couple of use cases, but to the hilt, I think really good. I will drop the link to its repo in video's description. Let me know what do you think. If you intend to use it in any production environment, or if you can think of any use case, let me know. Happy to hear out. Or if you are doing anything similar with any other product, especially with VLLM, please share your experience with us. It will be real good learning exercise. That's it, guys. I hope that you enjoyed it. If you like the content, please consider subscribing to the channel. If you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.